Hello, Robin. Hello, Mike.
Hi, Robin. Hi, Caio.
I think you are.
Hi, Caio. Hi, Mike.
Okay.
Yeah.
Thank you for joining us. So first question, are you an iOS developer?
Yeah, I am.
For how long?
Oh, like 5 years.
Awesome. So mid-level, senior?
Yeah, something
In
closer
between?
to the senior, but yeah.
Okay.
Awesome. How can we help you?
Yeah, I was a little bit struggling with generics and architectures and some naming and the way how to structure the apps with the SwiftUI and how to came up this all together.
Mm-hmm. Okay, so first of all, where should we start with? SwiftUI, naming, protocols, which one?
I will go ahead with the easier stuff like the naming, I guess.
Mhm.
That's...
Okay. So what is the issue with naming?
The issue with naming is to came up with some good name that represents the variable or the protocols and their concrete implementation. So sometimes you can end up with a protocol that's just protocoling, and then the implementation is just without the ing, which is, I don't think, the greatest naming conventions.
Mm-hmm.
And yeah, so that's...
Okay, so yeah, naming is one of those topics, that doesn't look like it should make a big difference, but it does. How you name things, it helps a lot with productivity of finding stuff in the code base, of understanding what it does and, communicating with other developers that are reading your code. So it is important. So we like to avoid too generic names when naming, for example, classes or protocols, because otherwise it can become a God class if you call it like a manager, right? You call it like a class user manager, for example. There's the problem. If the manager is such a generic name that you can put, like, if you're thinking about, okay, I have this method I need to add related to users, where should I put it? Well, probably in the user manager, because it manages users, right? And then you start extracting all the functionality, and suddenly this class is like thousands and thousands of lines long with hundreds of dependencies.
Yeah, exactly.
Yeah, so it's important to name things, like take some time, to think about what is this class about? What does it do? What is the goal of this class, right? And come up with better names. And sometimes you have, for example, protocol, as you said, you have like let's say a user store or a user repository. I have some methods here to, for example, get a user by ID. Like user if ID, let's say, returns a user. I see many developers calling this a user repository protocol, then calling the class that implements it a user repository.
Mm-hmm.
Yeah,
that's common,
that's
right?
quite common. Yeah.
Yep.
Or implementation.
Yeah,
user.
or don't call this a protocol, but then this is the implementation, right? Or put an I here in the beginning to say interface user repository, and then the repository implementation. Mm-hmm. But this hides the role of that implementation, the intent of that implementation. And I wouldn't put like an I here. I wouldn't put a protocol here as well. I also see people call this type, like a user repository type, and then implementation is just implementation. Because I don't create a class and say user repository class. I don't create a struct and say user struct. Make sense? So why would I call the protocol a protocol? When I'm reading the code at the point of views, if I have a property here in another class, like repository, I don't want to know if it's a protocol, if it's a struct, if it's a class, right? It shouldn't matter. What matters is that it's a user repository and that there are some methods there that I can call. The way I like to name things is that the protocol is going to name the type, like this is a user repository. Now the concrete class will be more concrete, like what type of user repository is this? For example, this could be a core data user repository.
Yeah. Going to see how the implementation is now specified in the name, right? By giving it the exact type of implementation, but without naming it as such, right? Like having the impl, for example, as a suffix.
Yeah.
Right. So user repository. When I'm typing user repository, autocomplete can tell me, oh, there is the protocol one, and there's a concrete implementation. Okay, I need the concrete implementation. And if I have, for example, I can create implementations of the protocol. I can have an in-memory user repository. I can have a user default user repository. I can have what defaults? Realm, which is more specific to the concrete implementation, right? So when I'm instantiating it, for example, user repository, I have all the options here. Which one do I want here? It helps with discoverability, right? I do need a user repository. And then here I have choices. Which one do I want? The realm one, the in-memory one. Maybe in testing, you're going to have a fake one, a stub, a mock.
Yeah.
So I like to call the protocol a bit more generic, of course. I don't want to leak details here. What I don't like as well is when I pass here like user with ID, and here it returns an NS managed object, for example. What is the problem? This protocol now only works with core data. So I already know what the implementation of this protocol is. So it's not polymorphic, right? It's not actually a protocol. It's very concrete.
Yeah.
Right. So I don't want to leak details in the protocol about the specific implementation. And I'm free to have different implementations of the protocol, for example. So the protocol has a more open name. It doesn't specify exactly the implementation, just defines requirements. I need a user repository that has one method that you pass an integer and it returns a user. Now, in the concrete side, I like to keep the user repository name, which is the name of the protocol, but specialize it, right? And give it more information. This is a core data user repository. So when I'm looking for a repository in the code base, I can find all the options I have. If I want to use the core data one, the in-memory, user defaults, and so on, a fake, a mock.
Yeah. Exactly.
And that's why I don't like to put like protocol in the name or type. No, the name should be as short as possible, but without losing context. Yeah, don't call it like user rip. Like, where is rip? Maybe at the time it made sense. Like, oh yeah, it's a repository. It's fresh in your mind. But 2 weeks later, you come here, it's like, what is rip again? So be short, but not as short. And the rule in the clean code book is shorter the scope, the shorter the variable name can be. Right? So if you have like a very tiny function here, a method, and you need to create a temporary variable here, the name can be short. Right? If you're calculating some frames, we can just call like X, Y. It makes sense, in the scope here. Or this function, like the shorter the scope, if you have like 2 lines here and it returns X, if it's very clear the intent of X, it's okay because it's a very short scope and there is context in the name of the method, for example. So the shorter the scope, the shorter the variable name can be. Doesn't mean it should be 1 line, 1 character, right? But the shorter the scope, the shorter the variable can be, as long as you don't lose context. Now, the higher the context, right? So, for example, a class name is part of a much larger scope, right? It can be used everywhere, but a variable within the scope of a function can only be used here in these 2 lines. So the name can be shorter because you have context in the scope of the function. Then when you can also define a variable or a property at the class scope, but then the scope is larger. Thus, the name of the variable usually is a bit larger to give more context. And then the name of a class is also in a larger, even larger scope, on the scope of a module, right? And then the name of the module as well is in a larger scope, and so on.
Yeah.
So names should be as short as possible. We don't want to have a class with like 300 words, of course, but without losing meaning, right? If you can pass meaning with 2 words, it's good enough.
Yeah. That was helpful, thanks. Yeah, and one of my next questions were regarding the SwiftUI architecture and its openness during the solid principles. How to basically make an architecture that is still open to scaling within the new SwiftUI app lifecycle. Because on one of your sessions I saw implementation of the UI hosting protocol, UI hosting view controller to UIKit and how to work with that. So you can switch between 2 frameworks of the UI. And my question is how to like go there with the new SwiftUI like logic and architecture.
So you're mentioning this quiz app here we developed in a series on YouTube, right? In one of the episodes, we showed that we built first this quiz app with UIKit, and then Apple introduced SwiftUI, right? And we bridged the two, and we had a hybrid solution. Some things were in UIKit, some other things were in SwiftUI. And then on the last episode, we completely migrated it to SwiftUI. Have you finished the series?
Yeah. Yeah, because right now we are thinking about like we have some parts of UIKit and some parts of SwiftUI, and we won't get to this like main and app lifecycle of the SwiftUI, and we still need to keep some parts of the UIKit. So basically, no transition to like SwiftUI, but get the app lifecycle of the SwiftUI with enabling some older parts of the UIKit.
Okay, so you want to do the opposite we did in the course, in the episode,
basically,
right?
Yeah.
So in the episode, we were still loading, for example, here, the old UIKit app delegate.
Yeah.
And here we would create a host controller, put a SwiftUI view, right?
Yeah.
So you can use the SwiftUI view representable protocols to bridge back with UIKit, and then you can have like UIKit views and UIKit components, right?
Yeah.
But maybe one strategy you can get is to use the app delegate as you have right now until you're ready, and leave the entry point as the last thing you do.
Yeah.
When you've done migrating everything. Right? But what is the benefit you see in using the SwiftUI
as the entry point?
As the entry point, if your application is not fully transitioned to it, do you see a benefit already?
The life cycle.
Yeah. Not exactly. One of my main concern is that the app delegate is basically doesn't then just is not like this single representation of the app, because right now you have the architecture of the SwiftUI app is just you describe the app, and then you have the app delegates to get the new information. But on the old implementation, the app delegate basically handles such a lot of stuff, like starting the app at extra. But yeah, I think going with the SwiftUI navigation adapter is one of the ways how to go, and then just remove the delegate and end up with just this app lifecycle.
Yeah, because do you support Swift iOS 13 yet?
No, because we are just enterprise app, and we basically
nice.
tell our user what iOS version should they use. So we are on iOS 14.4. So we have just free hands there.
Yeah, because there's still some limitations with the life cycle, with the quiz app life cycle. Here you cannot do everything you can as you can with the app delegate. You even have the UI adapter. Yeah, UI application delegate adapter, when you want to still load the old.
Yeah, I'm aware of that. Yeah.
Right. So here you can pass the class app delegate itself.
Yeah.
Delegate, for example. And if you set it like this, now when you load your app, you will load the app delegate you have. So you can do some extra stuff that you cannot do with SwiftUI yet.
Yeah, I'm aware of this communication there.
So this is something that can help. What else? You can use the UI view controller representable. Yes. Right, to bridge SwiftUI to use your old view controllers when needed, which is the other way around, right? You can have UI hosting controllers to host SwiftUI views, and you can also set up SwiftUI views that are backed by a UI view controller by using the bridging here, UI view controller representable, which is part of SwiftUI. So they bridge pretty nicely both ways. But I would probably try to use the life cycle here as the last thing, not as the first thing.
Okay.
But I don't know if it makes sense to you. Like I don't understand your project very well. Maybe it makes sense. So
no, I think that your solution makes more sense because this is still a really new app lifecycle and doesn't have all the things. So yeah, we'll definitely go with the adapter you invented there. And yeah, and regarding still the SwiftUI, I had one probably last question about localization. Where still with localized string key in SwiftUI, where it makes sense to continue with SwiftGen and generating the localization by that, or using the localized string key and basically have everything in strings and that.
So does it make sense to still use NS localized string, you mean?
Yeah, basically, yeah. Yeah, because the NS localized string is generated by the SwiftGen, I guess.
So you meaning SwiftGen as the tool that will check your project, find out like resources like strings, images, and create like static types that can be checked at compile time, right?
Yeah.
Okay. So with SwiftUI, mostly don't need to use localized strings. It hides that from you, right? You just pass the key and it does it behind the scenes. But I like to decouple localization from the UI framework. Like personally, with the projects I worked on, larger projects, it made sense to separate it from the views. Instead of using localized strings, even with UIKit, instead of using localized strings directly in the view, I would just pass strings that are already translated to the view. So the view doesn't need to do this logic, It just needs to render whatever string was passed, which makes it more dynamic. I can pass different strings in there. I can change dynamically the content without having to change the view, without if-else statements in the view. So, especially because translations, they are reused across apps and platforms. So usually I will move this logic to a component, like a view model that is decoupled from the framework. So I could reuse the same view model, the same strings in different applications, different platforms, in macOS, in iOS, in watchOS. But if it was in the view, I couldn't do it. I wouldn't be able to do it. I would have to duplicate the logic in AppKit, in UIKit, in WatchKit. But now SwiftUI is multi-platform, right? But even though I still separate localization logic from views as much as possible, because again, many times the content of the view is dynamic. There are some rules which content you should use. So the view is the same, but maybe the content is different depending on the state, depending on the logic. And I like to have this logic in a component that is decoupled from the UI framework, Because then when the UI framework changes, I don't need to change anything.
Yeah.
Right.
And in the view model, you will still use the localized string key, or will you go with, for example, the SwiftGen generated static?
I would probably go with an S localized string, and I will have tests, right? I have tests that check that. First of all, if I have a localized string, it will check if this string exists in a strings file. It's not missing, And in every localization that I support, it will also check that this string exists. And I will decouple as well my tests as much as I can from the current locale it's running the test, because it's very easy to write a test. Like, let's say the default locale is English, right? And you write your tests with like hard-coded English strings, and then someone is running your tests in Germany and it doesn't pass. It fails. Maybe your CI server, is in another country, and boom, it doesn't pass.
Okay.
So yes, I would use an S localized string to eliminate a dependency with SwiftGen. I try to eliminate dependencies. But if it makes sense to you, you can use SwiftGen. There's nothing wrong with it. I would just decouple my tests, my code from SwiftGen. This will be an implementation detail of my VO model. Right? I will not expose this publicly. I will probably hide it in the internal scope or private scope.
Yeah.
And that's an implementation detail, because if one day I decide I don't want to use SwiftGen anymore because it's not working with Xcode 16, they're not supporting it anymore, I can easily replace it without having to rewrite all the tests, without having to rewrite the UI, As long as it's hidden as an implementation detail, you can use frameworks, absolutely. Tools. It can really help, a compile time check that the resources exist and that you're using the right keys.
Yeah. Okay.
But if you have tests in place, this kind of static assets resources are not that necessary, because if there's something wrong, the test will fail as well. And then it's a matter if you want to check this at compile time or at test time, and which one makes sense to the use case. Because I think even though you have like static types, checking that you are actually accessing a resource that exists doesn't mean you are using the right key, right? You still need a test to make sure that the key you're using is the correct one. The compile time is going to tell you, hey, you are using a resource that exists. Fantastic. But not that you're using the right resource or the right image or the right string.
Yeah, exactly.
So you can have some snapshot tests, for example, to check that you're using the right things.
Okay. Yeah, thanks. Thanks all.
Make sense?
Yeah.
Awesome. Yeah, so it's a choice. You don't need to use it, but if he's going to help you, why not? Just hide it behind some internal scope, private scope.
Okay. Yeah, thanks. I guess that will be all.
Awesome. Thank you for joining us.
Yeah, thanks.
Thank you so much, Robin.
Thanks. Okay,
Bye.
see ya. Bye-bye. Yeah,
Bye.
you too.